exercise 5, we're told that the sum of the first 5 terms of an arithmetic sequence is 75, and the sum of the first 10 terms of the series is 325. And the question asks, what's the first term of the series? Oh boy. I gave you some pretty tough ones here, I think. This one and the one before it, exercise 4, are more like problems than exercises. And they require some algebra skills. So, but don't let that worry you, okay? It's not so bad. So let's just list out what we know. We know that the first it's an arithmetic series. The sum of the first 5 terms is 75. Okay, so that means the first term plus the last term of that series times the number of numbers, which is 5, all over 2 is equal to 75. Okay? So that's just converting this first statement into an equation. Okay? And we're using what we learned in this lesson, which is that the sum of the numbers is the first term plus the last term times the number of numbers divided by 2. Okay? So let's see. Let's go ahead and look at the second statement. The sum of the first 10 terms is 325. So we can just do the same thing. So we have a1 plus a10 times 10 over 2 is equal to 325. Alright, so let's take those two statements and kind of simplify them. I can multiply this by 2 and divide it by 5 and do the same thing to the other side, 2 over 5, and I end up getting a1 plus a5 is equal to 30. Alright, and then alright, so let's do the same thing here. Let's multiply by 2 and divide by 10. So multiply by 2, divide by 10. So doing that, we have 10 over 2, we multiply by 2 over 10, we get 1. So that will just end up being a1 plus a10 is equal to, I got 65. Okay. So now we have two equations, but we have a1, we have a5, and a10. So what else do we know? We know this is an arithmetic sequence, so we know that a5 is equal to a1 plus 5 minus 1 is 4. That's just n minus 1 times the common difference. So there has to be a common difference because it's an arithmetic sequence. And a10, whoops, I want a10, not 10. I want a10 is equal to a1 plus 10 minus 1 is 9d. Okay? And so let's see, we can do some substitution now, because now instead of a5 and a10, I'll have everything in terms of a1 and d. If I substitute in here for a5, if I put in a1 plus 4d, then I'll have an equation in terms of a1 and d. And the same thing here, if I substitute a1 plus 9d for a10, then I'll have everything in terms of a1 and d. Okay, so I'll have fewer variables. So let's do that. Okay, the first one, let's deal with this one first. So a1 plus a5 is a1 plus, and here's a5, a1 plus 4d. Okay, and that's equal to 30. All right. So you see what I did? I just anywhere I had a5 up here, I put a1 plus 4d because I know they're equal. And I can also plug in a1. here we go, a1 plus a10. So wherever I have see a10, I can say a1 plus 9d, and that's equal to 65. Okay, so I basically combined these two equations with these two equations, and rewrote them this way. Okay, and now I have two equations and I have two unknowns. All right, so then I can solve it. So but I would need to simplify these equations a little bit to make them a little easier to work with. So let's rewrite these. a1 plus a1 is 2a1. So I have 2a1 plus 4d is equal to 30. And 2a1 plus 9d is equal to 65. Now, I could divide this one by 2, but actually, if I just take those two equations and I subtract, actually I'm going to do this. I'm going to take the negative of this top one. I'll take the negative of that one because it's smaller, so my result will be positive. So then I get a negative a1 plus, I can add these two equations together. So if I have negative a2 and positive a2, that just becomes 0. So I have to distribute this minus sign among everything, including the other side of the equal sign. Okay, so I'm subtracting the top one from the bottom one. So as I subtract 4d from 9d, I get 5d. 65 minus 30 is 35. And then I can solve for d just by dividing by 5. And d is equal to 7. Alright, well, we got d now. Although we're not asked for d, we're asked for the first term in the series. So let's figure that out. Now that we have d, that's fine, because we can take either one of these two equations and we can put d in for it, and then we can solve for a1. So let's just take that top one. So we have 2a1 plus 4d. So I'm going to take 4 and substitute 7 for d is equal to 30. Now, 7 times 4 is 28, so I'm going to actually subtract 28 from both sides. And then this will end up being 0, and I'll end up with 2a1 is equal to 2. And then if I divide both sides by 2, I get a1 is equal to 1. Pretty cool. There we go. We got it. That is the first term of the series. It took a bit of algebra. But don't let that scare you. Really, it's not too bad. I think of algebra as being sort of like a game. You learn the rules for manipulating numbers, and you apply those rules to try and figure out how to solve a problem. So it's a lot like, maybe you guys have played chess, and you learn the rules for how the pieces move, and then you use those rules to try to figure out how to win the game. And it's the same way with algebra. It's a lot like a game. You learn the rules for how numbers work, and then use those rules to figure out how to solve a problem, like a puzzle. So, it's a lot of fun once you learn the rules of the game.